In this video we're going to look at how to find the area of a segment. So here's an example. We've got a sector and we've got a segment and it is shaded in grey, and we want to be able to work out the area of a segment like this. So to do that, what you're going to do is you're going to do the area of the sector subtract the area of the triangle. So if you get the area of the whole sector, this whole sector, and you subtract the area of the triangle, then you'll be able to be left with the area of this segment. So we're going to need to be able to do two things, and if you haven't watched the videos on them, watch the videos on them now. They're called area of a sector and area of a triangle, and that's using the sine, okay, or using trigonometry. So the area of a sector is given by pi r squared times by beta divided by 360, and the area of a triangle is a half AB sine C. Okay, so what we're going to do is we're going to work out these two things and subtract them, and then we'll be left with the area of the segment. Okay, so let's start by working out the area of this whole sector. So the formula is pi r squared, so pi times the radius of the whole circle would be 10, so times 10 squared, times by beta, which is 52, over 360. As I said earlier, if you can't remember doing this, look back in the video on that now. Okay, so let's work out what that is. Okay, so so pi times 10 squared times by 52 divided by 360. So there, if the whole sector is 45.37. and so on. Don't round this until the very end of the sum. Okay, so 45.378 and so on. Actually, what I'm going to do is I'm going to store that into the memory of my calculator, so then I can bring it back later. So shift, store, so store, and then A. So we've saved it into the calculator to use later. Okay, so now let's work out the area of the triangle. So the area of the triangle is going to be a half AB sine C. So this side's 10, and this side also is 10 because they're both radii, or that's a radius and that's a radius, so they're both radii. So we're going to do a half 10 times the sine of 52. So a half of 10 times the sine of 52. So let's work that out. So we're going to do 0.5, a half of 0.5 times 10 times 10 times the sine. Calculator needs to be if your calculator has an R at the top, it needs to have a D, so shift mode and put it into degrees mode, free. So 0.5 times 10 times 10 times the sine of 52, and that's equal to 39.40. So that's equal to 39.40. So let's save that into our memory. So shift store B. If you don't want to do that, you could just simply write out the whole calculator display here and the whole calculator display here and take them away from each other. That's perfectly fine. Okay, and then we're just going to do recall A, subtract recall B, and then that'll give us our answer, which is equal to 5.978. So area equals 5.9. We can write it at this point 5.98 centimeters squared. So this area here of this segment, the area would be 5.98 centimeters squared. All we've done is worked out the area of the sector, the area of the triangle, and taken them away from each other. Okay, now this time we're going to find the area of the segment again, but we haven't been given the angle. We've been given the length of the radius and the length of the overradius and the length of the chord joining those 2 points on the circumference. So what we're going to need to do in this particular case is use basic trigonometry to work out the size of this angle. You could also, I suppose, use the cosine rule, but I personally would just split it into this shape here, a right angle triangle. Okay, if we split it into a right angle triangle, this would be 5 centimeters, and you've got, so that's the hypotenuse. The hypotenuse is equal to 13, and if this is the angle, then you've got the opposite is equal to 5. So you're going to use sine. Okay, let's just do our basic trigonometry. So that's the opposite. That's the hypotenuse. So we've got O and H. So we're going to do skipped over heaven. Okay, we're trying to find out what the angle is. So we're going to do opposite divided by hypotenuse. So we're going to do sine beta equals opposite divided by hypotenuse. So it's going to be equal to 5 divided by 13. So we do 5 divided by 13 on our calculator and then press the inverse sign. So 5 divided by 13 and then do shift sign and then answer. So we get 22.619 so on degrees. So vita equals 22.619 so on degrees. But obviously that's only half of the angle. We need to times that by 2. So we're going to times this by 2. So times by 2 equals 45.24 degrees. So if this angle here is equal to 45.24 degrees. So that's what we're going to use within the question now. So that's now we know the angle, we can do it just like the ones like before. So we have got, let's just put this here, let's work out, first of all, let's work out then the area of the sector, the whole sector. So the area of the sector is pi r squared, so it's going to be pi times 13 squared times by vita. Well, vita equals 45.24 over 360. So we'll do that and we'll work out the area of the whole sector. So we've got pi times 13 squared times by 45.24 divided by 360. So the area of the whole sector is equal to 66.72 so on centimeters squared. So let's save it into our memory. Shift store A. Okay, now let's go and work out the area of the triangle. The area of the triangle is a half AB sine C. So we're going to do a half times. Make sure you remember the A and the B are the two lengths of the sides, either side of the angle. So we're going to do a half of 13 times 13 times the sine of 45.24. So let's work that out. Sorry about my handwriting here, it's getting a bit messy. So we've got a half times 13 times 13 times 13 times the sine of 45.24, which equals 60.000. So pretty much 60. So it equals 60 centimeters squared. So now we just need to take these away. So 66.72 subtract 60 would be equal to 6.72 centimeters squared. If you want to do that more accurately, make sure it's spot on. Use your calculator memory and use the values that way. Just to recap that one then. So because we weren't given the angle, we had to use basic, split it into a right angle triangle, because it's an isosceles one. Split it into a right angle triangle. Use basic trigonometry to work out half of the angle, double it, and then you know the angle. Then you can do just like before, find the area of the whole sector by using pi r squared times vita over 360, and then work out the area of the smaller triangle by using half AB sine C, and then take them away from each other, and then you find out what's left.